Thank you. Thanks for having me here again. I was here 3 years ago, and it's fun to come back here, meet new people, give you an update. Future brain, I'm going to be talking a lot about what is going to be coming in the next decade in terms of technology in the brain, but I feel like it's really important to ground it in what's going on right now. And what I've come to view as the most important global challenge we face, and I'll frame why that is in the context of all the other challenges we face, which is enhancing human cognition. And so what does that mean? In terms of assessing and optimizing cognition, and I'm defining that very broadly to include our attention, perception, memory, our reasoning and decision-making, imagination and creativity, emotional regulation, our empathy, compassion, and our wisdom, we're really tragically lacking. We know that over 500 million people around this planet are suffering debilitating effects of anxiety and depression and deficits in attention and memory. And these numbers are growing, especially with dementia in our seniors, but also with attentional and emotion regulation control deficits in our youth. And there are many other pieces to this that I don't really have time to break down, but I've come to view this as really the signs of us humans really being in a global cognition crisis. And as I said, I don't have a lot of time. I want to talk more about the future than the present, but I just recently outlined this in an article that you could look up called The Cognition Crisis. And I would like to propose that this goal of enhancing human cognition be positioned as a grand challenge, on par with the other pressing global priorities. Because if we can't focus our attention in a sustained way and make wise, creative, future-oriented decisions that prioritize others over ourselves, we will never effectively address other complex time-delayed crises like climate change, no matter how much information we acquire. So it's really core to our survival is to advance and evolve the functioning of our minds. Now, fortunately, we have these two giant global institutions that have been around for a long time that should be well positioned to help with this challenge, right? Our education system for healthy developing minds, and then our medical system dealing with cognitive deficits across psychiatric and neurological domains. The problem is that neither of them have really stepped up to address the challenges that we're facing right now. And I view this as due to 5 pervasive but deeply rooted limitations in these institutions. And I just want to break that down very quickly. The first is assessments. We do not use very sophisticated assessments to understand our cognition, whether it's healthy people or people that have impairments. The advances in cognitive neuroscience, which we use in our laboratory at UCSF, have not made it into the clinical world. And we do not assess cognition in young people unless we think they have some type of developmental challenge or learning disability. Otherwise, we just really don't actually understand what's going on in their minds. You can ask a teacher, who's the best kid in your class in math or reading? They know instantly. Who has the best sustained attention, or the best working memory, or the best emotional regulation? They don't know. So there's really a disconnect between the scientific enterprise of understanding cognition and what we do in the real world. But it doesn't prevent us from trying to treat. However, we have very poorly targeted tools to actually increase cognition. In the education domain, which really grew out of the Industrial Revolution, we're still largely focused on transferring information content, but not building the underlying information processing systems that depends upon. And our medical system, for 60 years, has really relied on small molecules to improve cognition. Now, there's nothing inherently wrong with that idea, but it just has not proven successful. We cannot target these selectively enough to the underlying computational unit of the brain, which is the neural network. And therefore, we always have to increase our doses to very high levels to get the effects we want, and we get pretty much just as many side effects as we do effects. And this is something that we have just not overcome after decades of trying to. The other problem with both of them is that they're completely non-personalized. Right? We base our prescriptive advice on large population studies that completely ignore all the individual differences of the brains in those studies. And the classroom has been struggling with not leaving a student behind, but not segregating classrooms, not really solving the problem of personalizing the learning process to each of the brains in their classes. Many practitioners, not all, think about these in silos, that you could address something as complex as human depression with a single pill. But probably the biggest problem is that these are open-loop systems, meaning there's a long, sloppy, non-quantitative cycle between how we intervene and how we update that intervention depending on how it works. You take a pill, you go home, you monitor subjectively your own effects and side effects, go back to your doctor, and then we go up or down 5 milligrams, right? That is the art of medicine. And I'd say it is just not good enough. These are not the fine details that we need to refine. These are fundamental problems in our entire global system of improving the function of our minds. I basically did a deep dive into looking at other grand challenges, and you're familiar with them, and they're important. Energy and climate change and water and infectious disease. Nowhere is there one really focused on improving the function of the human mind. Sort of surprising when you think about how important that is for all of those others to be addressed. So let's talk about how we could think about advancing both these systems to have targeted, personalized, multimodal, and closed-loop systems that rely upon better assessments. And what I want to propose to you is one way of doing that is through technology. Now, this is a complicated area. I actually wrote an entire book called The Distracted Mind, Ancient Brains in a High-Tech World. I'm not going to be talking about that at all now, but it's sort of the flip side of this. It's how technology, even from an evolutionary perspective, has really challenged in a fundamental way the function of our brains. It is very real. It is very concerning. But what I'm really fascinated with is how do we flip that story around? How do we start thinking about technology to enhance what makes us human as opposed to diminish us? And this is a really important time to have this conversation because we know emerging in the consumer space is virtual reality, augmented reality, motion capture, smart wearable physiological recording devices, and artificial intelligence and other machine learning algorithms. These are going to have a profound impact on how we interact with the world around us, with each other, and with ourselves. So we can either get out in front of it or try to deal with it after the fact in similar ways that we're trying to now manage social media and other technologies that we created without deeply thinking through its positive but also negative impacts on us. And so why might we think about technology like these, as well as the ones that you all have in your pockets or your hands right now, as tools to improve cognition? How can that even be possible? Well, the devil's in the details, but on the surface, it's really based upon some very fundamental premises of neuroscience that experience is a powerful driving force of human brain plasticity. This is really a non-contentious point in neuroscience. Of course, we have to figure out exactly how best to harness this. But I'd say this is the really exciting potential of technology, to create targeted, directed experiences that maximally harness the brain's plasticity, to enhance our cognition, refine our behavior, and I would say to ultimately elevate our minds. I think that is really the challenge that we have in front of us. So let's break down a little bit about how we might do that. Not all experiences are created equal. The ones that I'm most interested in are what we call closed-loop systems, or I think of as closed-loop experiences. This is probably one of the most important points I have, so I'm just going to pause here and tell you exactly what I mean by that. So a closed-loop system is one where you intervene and record the impact with as low latency as possible. So ideally in real time, you then use that data to refine your intervention. You apply it again, record, and keep cycling over and over again. At each pass through the closed loop, you're becoming more targeted to the outcomes you're trying to achieve. We use closed-loop systems all the time in all sorts of ways in the physical world. The thermostat in this room is a closed-loop system. It's sensing the environment, and it's changing a heating or cooling system to maintain equilibrium. We use very few, basically hardly any, closed-loop systems in medicine or in education. There's a couple that are just beginning to enter the world, but we really have not exploited this engineering principle, which has proved so powerful in many other ways. So how do you build a closed-loop system to improve cognition? One way, the way that I've become fascinated with, is through video games. Now, I know there's lots of views about video games. I've given entire one-hour lectures just on video games and the complexity of them and the complexity of views on them. And there's certainly issues around overuse and violence, and I don't want to talk about that right now. I just want to talk about the potential to create a closed-loop system using a video game to change cognition. How do we do that? So here's a cartoon. Your brain is playing a video game, right? It's your brain that plays the game, moves the rest of your body. While that is happening, your behavior is generating performance metrics, like how fast or accurate you are. This can be recorded by sensors on devices, like an accelerometer or a tap screen, to know how you're performing in the moment with no delay. That data can then be fed back through an environment, both the challenge and the rewards can be updated based upon how you're performing in the moment to give a perfectly tailored, personalized experience based upon your abilities. So the mechanics of the game activate brain networks in a way that we have never accomplished with any other approach. No molecule, no brain stimulation, nothing stimulates a brain network or activates a brain network like an experience. It's why and it's how our brains evolved. In 2008, I had this idea of building a closed-loop video game to improve cognition in older adults, which I've been studying for 20 years, aging in the brain. I'm not going to spend time breaking this down, but it's a closed-loop video game that basically challenges people across more than one domain. Driving this car, maintaining your position, and responding to these signs. And based upon our research, we suggest that this process would enhance other cognitive abilities that depend upon the same brain networks. And so we did a long 3-year study. This was a year of development, collaborating with LucasArts. And what we found was that if we look at multitasking performance on the game, 20-year-olds, despite the fact that they believe they're multitasking masters, suffer almost a 30% decrement in their ability to perform these two tasks at the same time. Now, that ability does not just maintain at that level for your entire life and then just plummet in one tragic year when you're 70. What happens is that it plummets every tragic year of your life. That's just the reality. What we found was that after a month of playing this closed-loop video game, our older adults were able to improve their multitasking performance essentially to the level of 20-year-olds. But most importantly, we confirmed the hypothesis that we also improved their attention and their memory on tests that were very different from the training environment. We published this in 2013 in Nature. You know, that's like the cover of Nature. It's being like being on the cover of Rolling Stone for us scientists. And what was most important here was that we started advancing the methodology, that we could move something like an entertainment video game that's custom designed into the world of first science and then practical applications. Okay. I'm just going to tell you a little bit about this company, Achille, that I founded. I basically published the patent behind the game. That's very important when you move something out of the lab and try to get into people's lives. We can't really build a scalable product at UCSF. So despite the fact that I didn't know anything about business at the time or intellectual property, if we actually wanted to get this into people's hands, I had to learn how to navigate this really complex relationship between academics and industry. And so I helped start this company, Achille, with folks from the video game industry, folks from the healthcare investment world. And what Achille has now done is taken the core technology that I described to you very briefly, but embedded it in a game environment that's much richer with art, music, story, reward, usability, all these things that lead to a deep, engaging, immersive experience, which I think is absolutely critical, not just for this to be used when we talk compliance, but also the depth of engagement is also important for engaging the plasticity processes that improve function. Now, Achille is very interesting. Although we've been around for years, we've never sold anything. So what we've decided to do is not take this game through a consumer route, but to take it through the medical device pathway. In order to do that, we have been doing, well over a dozen trials in all these conditions that you can read about there. The one that we're most excited about, because it's furthest along, was a phase 3 trial. So that is a prospectively designed, multi-site, randomized, placebo-controlled trial on a video game. And this was with children with ADHD. That trial is now completed, and we showed that we can improve attention in those children relative to a control group. What we're doing now is advancing this through the FDA with the hopes that this would be the first ever cleared digital treatment for ADHD. Right now, we basically have stimulants and the world's first ever prescribable video game. So this is a long process. We're very close, not quite there yet. It's really a de novo pathway. It's a new category of medicine, essentially, that we think of as a digital medicine. And all these other conditions, especially depression and early dementia, are moving along as well. Okay, back to UCSF. My lab changed dramatically. No one wanted to do the basic cognitive neuroscience work. We wanted to do what we think of as translational neuroscience. How do we use the methodology, the insights of neuroscience, couple it with the tech world to create new, more real-world assessments as well as treatments? I don't have time to break this all down. I just want to show you a couple of pictures of what our labs look like. They're not normal neuroscience labs. We're now building these all over the world. 12 more at UCSF, Lausanne, Nice, We're working in Shanghai. My wife Jo sort of leading that sort of global initiative. Super exciting. They look like they might be interactive media labs, and they function like that. But we also record deep dive physiology right outside this door. There's an MRI scanner. On the other side, we could do blood work. This is right in UCSS Clinical Research Unit. I certainly don't have time to tell you about all the technologies, but obviously there's a big focus on mobile and wireless just because of accessibility. We have a paper in review right now of foster care children in India that have suffered adverse life events playing one of our games, a meditation-inspired video game, that show we could have attention improvements and behavioral benefits even a year later. That's not published yet, but we're very excited about that data because it shows the accessibility of this technology. Also, moving this technology on the assessment side outside of just the clinical domain into classrooms. Remember I said we didn't really understand the cognition abilities of children that weren't diagnosed with different clinical conditions. If we understood it, maybe we could look at these as levers and try to allow every child to ultimately reach their potential if we know where the deficits lie. What we've been doing is also using both virtual reality and motion capture, as I described, to advance even further. So this concept of digital medicine has been an active area of development for us for over the last 8 years. Most people do not know anything about this because it takes us around 2 years to build every one of these games, all of which target different systems. They all bring art, music, story, and reward cycles to create that deep engagement that I described. And they use different output systems, different devices, neural recordings, as well as virtual reality. We just had a paper 2 weeks ago on the left. That's our game MetaTrain, that meditation-inspired video game that I described to you was published in Nature, Human Behavior, where we show that we can improve sustained attention in 20-year-olds after 6 weeks of playing a meditation-inspired closed-loop video game. Happy to talk more about that later. Where we want to go in the future is bringing all these together, something I think of as neuro-CrossFit training, and not step in that same pathway that we did with the pharmaceutical industry, which is to put silos around every single drug. These are much more effectively engaged in as a collection that's driven by your data in a personalized manner. Now that this is built, we do very deep dives. As I said, double-blind, randomized, placebo-controlled trials, first of its kind to really understand not just the feasibility and the signal that something important is happening, but also the mechanisms of action so that we can move forward in a more informed way. And then advance this both through our education and our medicine initiatives. And so what I described to you very quickly was targeted, personalized, multimodal closed-loop approach. So we're really excited. We don't think that this is going to be a replacement to our education or our current medical system, but a perfect accompaniment to it to pick up on many of its current weaknesses. Okay, I have very little time, but I want to step into the future, right? Because this is future brain. So where do we go forward from what I just described? Now, what's most exciting about it, although that's quite a beautiful way to look at the brain and has lots of value in just getting people excited about the brain and how beautiful it is, what we really want to do with that is to ultimately close the loop. How do we do that? Well, as I already told you, we're using performance data like response time and accuracy to guide gameplay. We have other games that use your heart rate. So a physical fitness game, physical fitness meets cognitive fitness, where your challenges are not just driven on cognition, but you move your body in the game, responding with motion capture, we record your heart rate, and then we target you right at the appropriate ability based upon your heart rate, so that we give you the appropriate physical challenge. If we could record your brain activity, as we're showing right now, in real time, we could feed that data into the game engine, and thus create a personalized approach to optimize those neural processing systems that most need to be improved. Right? This is a hypothesis. We think it'll be like almost like a surgical approach to improving brain function. We're also using this data to guide brain stimulation using electrical currents. So with that, we're able to show, and we have 3 papers on this, that we can enhance the learning curve. It's pretty crazy. Felt like science fiction, which is why one of our papers is just a replication of the one that came before it, showing that stimulating the brain with an electrical current, we use alternating currents, can seemingly increase the plasticity and the learning response. What we're trying to show now is that it increases the transfer benefits that we've seen. If we have slides, the next one is very visual. No? Okay, well, maybe I'll show you later, but I can tell you right now that we are another company called SenSync. I'll just pull this all together with this conclusion, and I'm happy to show you later. I have my iPad with me. But basically, what I realized is that while we're making big advances on the software side of digital medicine, we don't have what I'd view as like the ultimate digital medicine delivery device. And so I basically incubated a company from scratch around 1.5 years ago, and we created this big, beautiful device. It looks almost like a spaceship that you lay in. And what we do there is we stimulate our participants with visual, auditory, sensory, and tactile stimuli. Most of our experiences are built around nature. So what you do is you lay in here, you see, hear, smell, and feel nature experiences. While that's occurring, we're recording your physiology and adjusting the environment based upon your own real-time data. So nothing like this has ever existed before. It's really exciting to have built a prototype that actually lives at the Four Seasons in Hawaii right now. The first positioning of this is essentially as a spa treatment for relaxation and restoration. It's sort of the most practical way of building something that's very expensive quickly, but the ultimate goal is then to take that big device, bring it into medical centers like Neuroscape, and then validate it as a medical device. So maybe for some people, having a mobile app that's accessible is all you need. For other people with like deeply challenging post-traumatic stress disorder or depression, this type of system may be more optimized. So that's a little glimpse of the future and this rationale, and I'm excited to keep you all informed on what we're doing. So thank you.